stop mean between. I'll explain you that part in detail. Otherwise, I'll just go through it quickly so that we can practice on the numericals more than the theory part, which we have already discussed in the class. So again, I'm saying whoever has a query in one of the theory parts can just stop me in between, and then I'll explain that portion in detail. So the first topic in ray optics was the topic of reflection. All right, so in reflection, we saw the bouncing back of light from a surface was called as reflection. There were two laws of reflection, right? So yes, Khadija, what were the two laws of reflection? At least tell me one of them.
The incident ray and the refracted ray lie on the same plane.
Yes, and
The angle of incidence and the angle of refraction are always equal.
angle of reflection, not refraction.
Oh, yeah.
Okay. Yes, very good. Correct. Absolutely right. Angle of incidence and angle of reflection both are equal to each other, and all these three rays, incident, normal, and reflected ray, all of these lie in the same plane. Now we started with the spherical mirrors. That's just a portion of the sphere. So if you silver the bulging portion, you silver it, that is this becomes the concave, and the bulging part is available for reflection, and the inner concavity is painted with silver color or it is polished. So we say it is a convex mirror. So Mariam, you tell me which one of these is a diverging mirror and which one of these is a converging mirror. Mariam?
Concave is converging.
Yes.
And convex is diverging.
Correct. Right. So she is right. Concave will always converge and convex will always diverge. Now for convex, we have seen all the cases where it will form what type of rays and all that we'll discuss. These basic points all of you know by now. Everybody has gone through this. Everybody knows what's a focal length, what's the pole radius of curvature. Coming to the sign convention. See, for the sign convention, object distance is always taken negative because whatever, remember it like this, principal axis and the mirror. Anything above the principal axis positive, anything below the principal axis negative. Anything in front of the mirror negative, anything behind the mirror positive. That's it. Or the other way for this is that you go along with the incident ray, wherever is the direction of incident ray from the pole. If they are along each other, like this, see, behind it will be along, because we always see everything with respect to the pole. So it will be a positive. And if it is opposite like this, it will be negative. That's why object you'll always put in front of the mirror. So we say this is negative. Okay. So these sign conventions we have seen. Now the 4 basic rules for drawing the ray diagrams. So Rishita, you tell me, if a ray of light is parallel to the principal axis, from where it will go?
To the focus, ma'am.
Focus, right. And if the ray is passing through the focus, it will
go through parallel to the
it will become parallel. Very good. And if a ray of light is retracing its path, it means it is passing through the center of curvature. So these are the 2 rules. Just give me a minute, just a minute. Yeah, so these were the 4 rules. Ray of light parallel, passing through focus, which Rishita has perfectly mentioned. Passing through focus becomes parallel. And if a ray of light is passing through the center of curvature, it retraces its path. And for the mirrors, this is considered as the normal, whether it's the spherical mirror or these reflecting mirrors. And angle of incidence, if the ray of light strikes the pole, then incident ray becomes equal to reflected ray. Okay, incident ray becomes equal, angle of incidence becomes equal to angle of reflection, means the law of reflection is obeyed. Now, real and virtual images that can be obtained, that cannot be obtained. Now, by now, everybody knows this. So, when the object is put beyond C, image is formed between C and F. This you can see images of small size, and it is virtual, real and inverted. At the center of curvature, at the center of curvature, the same size image is formed at the same position, means at the center of curvature, and it is of the same size, right? And for focus and center of curvature, now when it is between C and F, it will be opposite. When it was from infinity, it was between C and F. Now when the object is between C and F, image will be formed at infinity. Also, when this is the only case where you can get the image as virtual and erect, when the object is put between focus and pole. Okay, so you extend it and you see a virtual object is virtual image is formed. Now for convex mirror, see, it is diverged. It has reflected the light ray where you are seeing producing it and then seeing. So object will always be kept in front of the mirror because the bulging part is available for the reflection. This derivation can come in your exam for 3-marker question, 2-marker question. And the conclusion is that focus is half of the radius of curvature. Mirror formula is there in your syllabus. Mirror formula's derivation is also there. And this comes along with the numerical of the mirror formula also. So practice this, see all these derivations are important. Focus, mirror formula. And mirror formula basically says 1 by f is equal to 1 by v plus 1 by u. Magnification is ratio of height of image by object. So it is written as minus v by u for a mirror, v by u for lens. Okay. Now this is how you see the magnification. If magnitude is equal to 1, so same size, less than 1 diminished, more than 1 then magnified. Positive and negative will tell you virtual and erect or real and inverted. This numerical we had seen. Okay, all these questions. I'll start with this. Plane mirror also we have discussed. See, in the plane mirror part, these are some properties. Basically, you have to remember that magnification is equal to unity, distance of image is equal to distance of object, and virtual and real images both are created here. Number of images are very important. 360 degree divided by theta minus 1, whatever theta is given. Okay. Now, for the number of images. Then we have the concept of refraction of light ray. Okay, in the refraction, what happens? The original path of the ray is deviated, whether it is towards the normal or it is away from the normal. Bending of light rays, basically. Yeah, refractive index. Refractive index tells us about the optical density. What is the formula of refractive index? See, you can take the speeds ratio also. You can take the wavelengths ratio also. Wavelength in air by wavelength in the medium. Speed of light in air by speed of light in medium. So speeds are also taken, wavelengths are also taken. So that's why the formula will be lambda 1 by lambda 2 equal to V1 by V2, like this formula. Okay. This question, these two questions we have already seen. All right. Then the concept of apparent depth. Apparent depth formula also, please see everyone, the formula of apparent depth, that also you have there in your syllabus. So apparent depth is what? Sine I by sine R is apparent depth by real depth. What is sine I by sine R? This is the Snell's law, which says that this is equal to 1 by n, where your n12 or n means n1 by n2. So how is it related to your apparent depth? What is apparent depth? Apparent depth is the depth that is just visible to you. It is not the real depth that is present. Okay. Yeah, what is the formula for shift? The shift.
dr into 1 minus 1n, 1 by n.
What? Yes, dr into 1 minus 1 by n. 1 minus 1 by n, no? Yes.
Yes, ma'am.
Right. D minus 1 by 1 minus n. See, basically, wherever the apparent image is formed and wherever the real image is present, that separation, like if this is the apparent image, let's say, this is the real image which is present. So their separation is the shift. Like this real object has shifted to here for us. So this is the shift. So very good, Yaya. Your answer was correct. So few questions we have seen from this. Now from total internal reflection, one question is there that is very important. We'll practice this right now only before we move on to any other topic. What was TIR? See, TIR's formula, more than anything, you have the concept of critical angle. So for critical angle, Siddhika, what is the angle of refraction for critical angle? Siddhika. Angle of refraction for critical angle. Critical angle is the angle of incidence. Can anyone answer?
90 degrees, ma'am.
90 degrees, right. 90 degrees. So the angle for which, angle in the denser medium for which the angle of refraction in the rarer medium becomes 90 degrees, your critical angle. And the ray always goes from denser to rarer for the TIR to occur. Now, when the ray of light gets totally internally reflected within the system, it is called total internal reflection. All right. Taha, can you tell us this again? What are the conditions for TIR? Can you just mention this again? Conditions for TIR?
When an angle of incidence is greater than critical angle,
Yes. And?
and light travels from denser to rarer medium.
Correct. See, angle of incidence is greater than the critical angle. Means when this critical angle is crossed, then only TIR occurs. And ray has to go from denser to rarer. This is the condition of it. So when we apply Snell's law, we get this. So here, basically nothing different is there, just application of Snell's law is there. Okay, so these few questions also we have seen from this. And these were the applications of TIR which we have seen. Now this is a question. This question has repeated a lot. Please write down this question first. I'm reading it. So then you can copy. Just listen first before writing. A point source of light S is placed at the, this is written, this is S. Okay, a point source light S is placed at the bottom of a vessel containing a liquid of refractive index 5 by 3. A person is viewing the source from the above surface. Okay, there is an opaque disc of radius 1 centimeter floating above the surface. The center O of the disc lies vertically above the source S. The liquid from the vessel is gradually drained out through a tape. What is the maximum height of the liquid for which the source cannot be seen at all? First, write down a question. Write down this question. Written.
1 minute. Done, ma'am.
See class, this question is like, this is the vessel. In the bottom of it, the source is kept. Okay. This is saying a disk has formed. So like this disk is formed of the radius r. Right, this is what it is saying. There's an opaque disk of radius 1 centimeter floating above the surface. Now this is the disk. So see, when you have to find out the maximum height for which the source cannot be seen at all. Now look, if I see this separation from the source, let's say this is some height h. Now when this source will be emitting light ray, so this will be refracted at the surface. This will also be there. See, this is the height. Let's say this is some point A. This is some point A. This is the S. This half is enough for it. And this is the center O. Okay. Angle of incidence will be this. Now, what is the question saying? Look, a source was placed on the bottom of a liquid surface containing S. Refractive index is 5/3. Opaque disk is formed. The opaque disk is there floating above the surface. Now the center O of the disk lies vertically above the sources. That's why I have drawn it exactly in the center like this. The liquid from the vessel is gradually drained out through a tap. Now, what is the maximum height of the liquid for which the source cannot be seen at all? See class, if I do not make it like this, if it is not getting refracted like this, if the light ray is somewhat getting like this, refraction will occur. This is the vessel having the fluid. There, the disk is floating on it. Right, this is the fluid part. Okay, this entire is the fluid part in it. Now, if the light ray, suppose this, So the viewer will be able to see it. If it is not getting deflected, this means that this is getting refracted, right? Refracted by 90 degree. That is the only possibility, because otherwise, if other refraction is possible, then what will happen? If the other refraction is possible, then this light ray which is present, this will be entering the observer's eye, but it is saying it cannot be seen. If this is the case, now if you try to view, the light ray is not coming to your eye, so you'll not be able to see. So indirectly, the question has mentioned that this angle is what? What is this angle? Class, here the light ray, see, this is gazing along the surface. What will be this angle of incidence? Yes, Yaya?
Ma'am, where the mouse is, what angle is that angle?
This angle.
Angle of incidence?
Yeah, angle of incidence. Which type of angle of incidence? For which, see the refraction here.
Critical angle? For
Critical angle. See class, the angle of refraction is 90 degree here. So you have to identify, this is the case of the angle of incidence here is basically your critical angle. No? If it is not your critical angle, then how will it be the refraction case? Okay, this is basically like this. This is the height. Okay, what will be this separation? This will be under root r square plus h square. Okay, this is it. Now, this OS is what? This OS is basically the height of it. This is the height of it. Now, this is the angle I, which I am referring to. This is the angle of incidence I, which I am referring. Siddhika, now can you at least tell me what will be sine I from this triangle? What will be sine I? Yes, Siddhika? Okay, Sufyan, you tell.
R by root R plus R square plus H square.
Correct. Very good. Perpendicular upon hypotenuse. Perpendicular is r. Hypotenuse is under root r square plus h square. Okay, so this is the sine theta, because now we have to find, our purpose is to find out this h. Okay, we are trying to find out the h. That is the question. Okay, so sine I is there. Now, this is the critical angle. So what I can say? I can simply say sine I is equal to 1 by mu. That is the refractive index. Or let me mark this as n. Refractive index is given, no, in the question, 5 by 3 or something. So this is mentioned in the question that this is n, 1 by n. Now, the disk is mentioned already. This is the disk that is floating. This is the critical angle, which is sine I is equal to 1 by n, that is mentioned. Now, sine I is also this, and we have also used our trigonometry to find out the value of this sine I. So this is sine I, this is sine I. We can equate both of these. Both of these can be equated. So we can write 1 by n is equal to r by under root r square plus h square. Okay. Now, let me square it because this root is there. So 1 by n square is equal to r square by r square plus h square. Let's cross multiply. So r square plus h square is equal to r square into n square. What is h equal to? H square equal to? H square is equal to r square n square minus r square. We can take common r square. Siddhika, now answer what will be left if I take r square common from this. If I take r square common, if I've taken out r square from this, what will be left here? Take r square away from this. What will be left here?
N square.
N square. Right. Minus. If I take r square from here, then what will be left?
Nothing.
1 will be left. Okay. 0, you won't
Yes.
take it as 0. You will see 1 will be there. See, when you are multiplying this, no, you should get this back. So r square n square minus r square. So this is the equation of h that we are obtaining. Now what will be the height? It will be root of it. So r square can be written as r, but this will be under root n square minus 1. Now we know the radius also. We know the refractive index also. So this question is very easy now. R is 1 centimeter. So even if you write it in the SI unit, it will be 10 to the power minus 2. Refractive index is given as 5/3. So whole square minus 1. Now it depends in whichever unit you are taking. If I take this as 1 only, so the answer will be in centimeters. If I multiply 10 to the power minus 2, answer will be in meter. So I'm just leaving it in this only. So height will be 25/9 minus 1. This is 16/9. That is 4/3, which is 1.33 centimeters. Is this question clear to all of you?
Yes.
Yes, ma'am.
Yes, ma'am.
Basically, the important part was that sin I till here you could do through the figure. This part was there according to the critical angles condition, because this is gazing along. If why did we make this figure only? Disk is just above the source was mentioned in the question. Why did I take this incident ray? And when the refraction occurred, why I didn't make it something like this? Because it is saying source cannot be seen. So it means it is like this only. Okay, write down the solution. Done?
Yes, ma'am.
Then we saw the spherical refracting surfaces. So these two derivations are also, they are very lengthy, very important. So this is, see, you have to be very careful when you are deriving it from the rarer to denser or denser to rarer surface. Okay, so this is n1 by minus u plus n2 by v is equal to 1 by r into n2 minus n1. And denser to rarer is n2 by minus u plus n1 by v. N1 minus is equal to n1 minus n2 by v. So then you have the lens maker formula. So lens maker formula gives a formula that relates with the refracting surfaces. Both the refracting surfaces are included here, right? Two refracting surfaces are included this side. So one refracting surface, another refracting surface. So this is the derivation. Derivations I'm not discussing again. That's what I'm saying. Anyone wants me to discuss anything again, you can stop. So these are the two formula, lens formula and lens maker formula. Lens maker formula is 1 by f is equal to n21 minus 1 by r1 minus 1 by r2. And your lens formula is 1 by v minus 1 by u. Mirror formula is, what is the mirror formula? Yes, Mariam, what is the mirror formula?
1 by f is equal to 1 by v plus 1 by u.
Right. So in mirror formula, you have plus. In the lens formula, you have minus 1 by v minus 1 by u. All right. So this question we have practiced. Then equal lens, and when the lens are getting half. So I told you this can come as when if a black tape is wrapped around the lens like this also it can come. We saw when can the lens be see, the lens are also fixed, which can be diverging or converging. So Khadija, which is the converging lens? Concave or convex? Khadija. Converging lens. Recall all the ray diagrams.
Convex.
Rishita. Okay, yeah, Khadija, you're answering.
Convex.
Convex, right. Convex is converging.
Converging.
Concave is diverging, right.
Yes.
So if the refractive index of the glass is greater than the surrounding, then only it can converge. But if the refractive index of the surrounding becomes greater than that of glass, then it can diverge also. And this is the invisible lens case. When both the refractive indices are equal, then it is the lens. Lens maker formula, magnification, you have V by U. Same rule for magnification for both mirrors and lens. This is a question from your NCERT only, and it has come in the board exams. In the 5 marker section D also, this question has come. Okay, optical instruments. So optical instruments, what all things we have seen in the optical instruments? We saw that microscopes are there, which can be simple and compound, and then we saw telescopes. And then we saw that two cases are there where the least distance of distinct vision can be there or the infinity can be there. Now, in the simple microscope, if least distance of distinct vision is there, the formula of magnification is 1 plus d by f. And if it is formed at infinity, then it is simply d by f. And these questions we practiced in the class. Then come the compound microscope. If the formula, if you have the compound microscope, this is V naught by U naught, 1 plus D by Fe, V naught or U naught. These are the objective lens, and E is the eyepiece. So V naught by U naught, 1 plus D by Fe. And in the case of infinity, this 1 goes away. So V naught by U naught into D by Fe. These two formula also I have told you regarding the length of the tube. V naught by U naught is L by F naught. So where you can write V naught U naught as the objective lens only. Okay, these questions we have seen. Now, this is the question. Please try this first. magnification power of astronomical telescope? Okay, just wait. There was one more question. Wait. Yes, class, please note down this question and please tell me the answer for this. It is saying a biconvex lens has a focal length 2 by 3 times the ratio of curvature uh, of either surface. Okay. So this is basically, this says that calculate the refractive index. This is radius only. And tell me the answer of this too. Tell me what is the refractive index. Yahya's answer is right. Sufyan, Mariam. Okay, only 4 students have answered. Sufyan, that is incorrect. Taha, Mariam, and Yahya, your answer is right. See, focus is 2 by third of the radius of curvature. Radius of curvature is our second because it's a by convex lens. It will be minus r. 1 by focus is mu minus 1. This will be 1 by r1 minus 1 by r2. Okay. So 3 by 2r will be equal to mu minus 1, 1 by r plus 1 by r. So this will be 3 by 2r is equal to mu minus 1 by 2 by r. R gets cancelled. 3 by 4 is equal to mu minus 1. Mu is equal to 7 by 4, which is equal to 1.75. So how 4 by 3? I think okay, you just calculated till here. Okay, those who have not written, quickly write down this. Done? Done, others? See class, this question says the magnifying power of an astronomical telescope is normal, in the normal adjustment position is 100. Okay, magnification is given as 100. It is saying the distance between the objective and eyepiece is given as 101. Means f0 plus fe is given as 101. You have to calculate the focal lengths of objective and eyepiece. See, what is the magnification? In normal adjustment means when you're calculating the magnification for an astronomical telescope. So it is f0 by fe. Okay. So f0 by fe is given as 100. So f0 will be equal to 100 times fe. Right? Now, if we put this here in this formula, it will become 100 fe plus fe is equal to 101. Right. So 100 fe plus 1 fe means 101 fe is equal to 101. So fe, focal length of eyepiece, is 1 centimeters. And if this is 1 centimeter, so f0 is 101 minus 1. So f0 will be 100 centimeters. So this is a question from telescope. Okay, please write it. Done.
1 minute, ma'am.
This question is saying a simple microscope is the combination of two lenses in contact. Powers of the two lenses are plus 15 diopters plus 5 diopters. You have to calculate the magnifying power of the microscope if the final image is formed at 25 centimeters from the eye. See class, it's a very easy question. When you have powers, the net power is always given by addition of all the powers. Okay, just sum of the powers will give you the resultant. So 15 plus 5 will be equal to 20 diopters. So plus 20 diopters is the power. Okay, we have to find out the magnifying power of the microscope, right? Now, for the magnification, focal length is 1 by power. Okay, that will be 1 by 20. Okay, so this will be 5 centimeters because this is in meters. So it will be 5 centimeters. So the focal length is there, magnification for simple microscope. When it is from 25 centimeter from the eye, this is which distance? Yes, class. What distance is this? 25 centimeters. What do we call this?
Near point.
Yeah, that is the least distance. Correct. So 1 by d by f. 1 by 25 by 5. This is 4 plus this is 5. 5 plus 1, 6. This is the answer. Please write this. Okay, this says that an object to be seen through a simple microscope of power 10 diopters, where should the object be placed so as to produce maximum angular magnification? Least distance of distinct vision, you already know it is 25 centimeters. So power is given, maximum angular magnification is asked for, the least distance of distinct vision. And you know it's which type of device is this? This is the simple microscope. So this is similar to the previous question. See, least distance of distinct vision is there as 25 centimeters. Okay. Focus, you all know it is 1 over power. So it will be 1 by 10 in meters. So that will be 10 centimeters, right? 10 by 100 will be 10 centimeters. Okay. So this is the focal length. Now 1 by u is equal to 1 by v minus 1 by f. So here we have the focus. V is minus 25 because it is how it is kept at least distance of distinct vision. So it will be minus 1 by 25 minus 1 by 10. So this is minus 7 by 50. Yes, this is 7 by 50. 2 and 5, yes. So the object distance will be minus 50 by 7, which is equal to minus 7.1 centimeters. Okay, please write this. Is it clear to all of you?
Yes, ma'am.
Use this formula. Okay, write it. Okay, class, all those who have completed, you can leave. In the next class. We'll continue with this ray optics only. So please revise and come. Questions are left. Questions practicing we'll do. Many questions are left that have to be discussed. Okay. So in the next class,